working group meeting. At 3. We'll do this one at 9.
Okay, gotcha.
And the Carpenter Working Group is occasionally at 9 a.m. itself. So it's one week out of the 4 weeks of the month. We'll do this one that we're at, the DRA one, at 9 to
Okay,
avoid collision with the Carpenter.
Yep.
That's the easiest way to think about it. So it'll be at 3 out of the 4 times.
Yep.
I gotcha. I see it on the calendar now. Okay.
All right. We're here on behalf of SIG Autoscaling and the Carpenter Project to discuss DRA integration into Carpenter. I'll go ahead and announce the standard CNCF disclaimer material. We'll be kind to one another and abide by the CNCF code of conduct. And without further ado, Jason and Alima, let's get sort of up to speed with some micro progress that was made. Actually, Alima did a lot of work before she went on vacation to put together a naive, and I mean that in a complimentary way or like in a factual way, a naive representation of the Carpenter architecture and how we might move forward with accommodating that architecture for DRA. Do you have an easy way to screen share,
I
Alima?
can
Do you want
screen
to like walk
share.
through the RFC doc? Cool.
Um, okay, I was just kind of going over how I structured this. Jackie already noticed like this is kind of what we want our rough draft for the RC to be. And then this is just draft work for specifically just scheduler. So this is how it works right now. And I can go through all the steps, but I literally would just look through the code and then I would try to just understand it. And then if I didn't understand something, I would ask Copilot to explain it for me. Um, yeah. And then after that, I just thought about the ways that we would want to integrate DRA into that. And then all the DRA additions to this, I added in bold right here and then added in bold on the diagram. So yeah, very naive. Um, do we want to go through this together right now?
Yeah, I think so, because as I said before we started this meeting, I've been out for the past couple of weeks, so I haven't had a chance to work
Okay.
on this since we last
Um,
talked. So yeah, I
yeah,
think we got lots to share.
I think here it's a little easier to view because you can view it side by side. Um, let me just change this format. Oh, okay. Oh, that looks so bad. Okay. Um,
We can maybe just if to me the visual stuff is actually pretty clear, and then Jason can
okay.
help
I
sanity
think
check
I
it
need this
for
because I haven't,
correctness.
I think I need this because I haven't looked at it since I came back. But yeah,
Cool.
first step is the initialization. So let me pull up scheduler.go. Um, yeah,
So
so
let me stop just for 1 second,
mhm.
and confirm with Jason
Mhm.
what my assumptions are at this stage. So if we can assume that this is more or less correct, the creation of a node claim will, let's assume in a DRA world that node claim, or do we have a separate visual for the DRA? Is this just trying to describe?
Yes, we do.
I see. Okay, cool. Then I probably shouldn't interrupt. Maybe I should just let you
Well, do we
go
want
ahead
to
and
go,
describe.
would we rather describe the DRA then?
Well, why don't you let's quickly make sure that any misassumptions are covered, because those
Yeah,
are
I
going to be
agree.
inherited by our DRA flow as well.
Uh-huh. Yeah, but first it's initialization. So like for every of these node pools, we would like filter the different instance types like based on the requirements. So like some node pools wouldn't work for like our instance type requirements. Then for every node pool where the instance type could work with our requirements, it would create a node claim template. And then this is, we can skip over, yeah. And then the next part is it would create the pending pod priority queue. So we would sort the pods in decrease in wait, descending, I think. So yeah, descending order by CPU memory.
Yeah.
So like this specific algorithm is like that first fit decreasing bin packing. So then it's like the ones at the top would be the pending pod with the highest CPU memory requirement. And then also we want to cache this data so we don't have to recompute this every iteration. Yeah. Then step 3, these are like I have like 3A, 3B, 3C. Iteratively, we're trying to place the pod. So first we're gonna do the running nodes first. And one thing I noticed about this is we're trying to first do the running nodes that are least loaded. And that's for load balancing reasons. I didn't know exactly what the reason was for why this is like helpful for load balancing, but I assume there's a very good reason why. So yeah, so first trying the running nodes. If it's a valid fit, then we would add the pod to the node. Um, then we would try in-flight nodes right here. This is also least loaded uh, node claims first. And then if it's a valid fit, add it to the node claim. So like to distinguish this 3A, we added to the node, 3B, we added to the node claim. Then if those two options don't work, like it's not a valid fit, then we will create new node claims. For each node pool template, we want to filter by the instances. And yeah, this is where we do like we create the new node claim for the cheapest option and then try to add the pod. And then if it works successfully, then we update accordingly. If it doesn't work, then we actually destroy this node claim and then continue to the next like node pool option. So I have here a diagram just like 3 of these for the 3 different types, but like there will be many node pools that would be signifying 3A, 3B, and 3C.
Yeah, right. By the time you get to 3A and 3B, you aren't really even thinking about it at a node pool level at that point. It's really just a group of node claims.
Group of
Uh,
node claims. Okay.
yeah, and the idea of 3C, which I think you pretty well got, which is we're going to iterate through all of the node pools from highest weight to lowest weight. And the first node pool for which a pod can fit, we're going to create a node claim using that node pool and schedule that pod to it. And then that node claim we just created goes into the set of in-flight node claims in 3B for future iterations.
3D,
3B.
3B, 3B. Okay, gotcha. Yeah. What was next? Let's see.
And honestly, I think this covers the important aspects of it for our.
I was going to say, I think this is thorough, and I think more or less the set of behaviors that we have to worry about for DRA.
Yeah.
Okay. I mean, the
There's
last section was just like if this whole process doesn't work, then we start to relax preferences and then requeue the pod. Like if it doesn't work, there's like a hierarchy of preferences where we would want to remove constraints. That was all. And
yeah.
then you just continue.
Yeah, we don't need to worry too much about that for DRA because
Oh, really? Okay.
basically what we're doing is we're mutating our in-memory representation of the pod and just redoing the same scheduling simulation against it.
Yeah,
Wait,
actually,
sorry, can you
just so
repeat
we can
that?
get on the same page, Jason. Go ahead. Why don't you ask your question first, Alima?
Mhm.
I was just gonna say, can you repeat why this is less important for DRA? Because I thought it was important. Because my thinking was that like if all the like we also need to have like a DRA hierarchy for preference relaxation. Like we need to add DRA functionality to this.
So I don't know for sure. Okay, so I didn't realize.
That's what I was going to say too. So
Okay.
I was going to say maybe there's an asterisk where there's some discovery work. I don't fully understand how Carpenter would like what constraints fall under like the category of able to be relaxable, and if there are DRA equivalents that would then suggest that we need to evolve that behavior.
Well, at this point, you have done more research into this than I have. So if there are some basic
There's an order.
preferences,
Yeah, so the way that the preference relaxation works is that you relax it from most restrictive to least restrictive. And then these were the different like
And again, this
constraints.
happens this happens if the entire enumeration has resulted in no available, like either the existing nodes on the cluster, the nodes that are in flight coming to the cluster, and all the set of possible node claims.
yep.
None of
Yeah,
those have a fit for the
yeah.
pods. So this is like
So
a default fall through. So like literally Carpenter has no way of knowing how to schedule the pod.
Yeah, yeah. If it just isn't possible, that's where we start cutting off those preferential constraints, whether that's node affinity, pod affinity.
yeah, if
Very
it's not
interesting. So
possible,
what
but then it
is that
also
a configurable
checks.
thing? Like can users say I don't want this relaxation? Because I could see how that could be somewhat
It can.
controversial.
So there's like
Oh,
this, it only does this if it doesn't, there's like a specific error if it's not reserved offering. I forgot exactly what a reserved offering was, but I think it was like a thing where if it doesn't,
this is,
um,
I can speak to this because this is,
okay,
um, that's a little bit different. Basically, the way we ensure that we use to ensure that we use all of the reserved capacity for like capacity reservations, um, while also maximizing the instance type flexibility we can send in AWS's case to create fleet. It actually can take multiple scheduling simulations, and we don't want to fall back. We don't want to fall back to other node pools or relax constraints until we ensure we have actually exhausted all of our reserved capacity. That part is a little weird. It doesn't actually have to do with preferences itself, it's general fallback behavior.
I mean, from a high level, I would imagine what you're doing is the same thing of trying to optimize for cost. So you're paying for reserved capacity. And so the idea that you would have an autoscaler that's essentially letting all of that idle while creating a bunch of new infrastructure, but you're going to have a bad day if you're a user because you're just wondering, well, if it's autoscaling, if it's creating all this new infrastructure according to unmet, workload requirements, why can't I'm already paying for this like reserve capacity. You should use that first. So I can see how that balance is really tricky.
Yeah, and that's what it's designed to do right now. It does do that at the cost of pod scheduling latency because it can take multiple scheduling simulations because we
Yeah.
don't know for a given node claim which reserved instance it's going to launch into.
Yeah.
Um,
wait, so is this right? Like, like when I said this reserved offering error,
that is
like
for
it went,
falling back in general. It's not just for preferences. So it's right, but there's also a little more to it.
okay, let me, uh,
Like I think honestly, in terms of just documenting the scheduling behavior for at
okay,
a higher level for DRA, it's safe to ignore that and think about that more during implementation.
okay, I see. All right, we can, yeah,
Yeah, but as a general rule, we just don't want to fall back. If we get a reserved capacity error, um, we just don't want to fall back.
So
yeah.
this sounds super interesting and but also super tricky. I would just say from a very, very practical division of like how do we decompose this large scope of work. This is probably phase two, but we
Yes.
definitely want
Okay.
to come back to it. I mean, we could even um, we could even ship an MVP of DRA with this, like just like if DRA is enabled, just don't do any of this stuff as a way. I don't know if there's an analog in cluster autoscaler, but this seems like somewhere in the area of like optimization that we should worry about at some point. But I could argue that for users who are using DRA in the most common ways, this is not gonna come into play, and so it might just be practical to kick that to a phase two.
Are you thinking preferences in general, or
I am thinking preferences in general. I'm thinking of like something as simple as like detecting that part of the workload constraints are, DRA, whether it's there's a resource claim template reference, or it's referring to a device class or something else to kind of short circuit any possible preference relaxation. And as an initial phase, say if we get to the point where we have not been able to find a node uh, for a pod spec that has DRA metadata in it, then we just fail the schedule.
I think for what it's worth, I think trying to scope it into this initial discussion complicates things just because there's already a lot going on with the scheduler as we're talking about it. The actual implementation of it should be relatively straightforward. Uh, the
Okay, cool.
preferences, the preferences
We'll take
fallback code
care.
is relatively simple.
Okay. Um,
Cool.
okay.
I'm super happy that Alima, you seem to have come up with something that's mostly correct. So that's
Yeah, it
great.
was really good for me to just go through it. Um, yeah. Wait, so I think like I'm hesitant to even explain my thinking for this because I don't think I'm the one with the background information to do all this. Like this is me just researching and then also like co-piloting and just like looking at the code and being like, oh, like what if we did this? So I'm a little nervous to even present this. It feels very like um maybe not productive. But let me know what you guys think.
I think the three of us together, we can figure it out.
Okay.
I'm happy to be the naive person. I know that we've gone over this a little bit, Alima, but it's been probably a week or so for me as well. So,
Okay. Well, let's
night,
go.
go ahead.
Well, we can take a shot at it. I just didn't know.
Well, the
Uh,
two key things are the scheduler and the node claim. So um, how do we evolve the scheduler in Karpenter so that it is aware of all the DRA things? So maybe I'm skipping a little bit ahead to just like division of labor, but we're gonna need to account for that. And in terms of the flow, so the Karpenter scheduler, Jason, evaluates node claims for, or does it evaluate? Sorry, did it does yes. My question is, does it take in workload metadata pod spec data and look for a matching node claim to pair it with, or does it look for a matching node and then create the node claim?
So are you talking about for like nodes which do not yet exist? So because it
Right.
does.
I can see how that's a different thing. So for nodes that exist, there already is a node claim. Literally, there's a one-to-one
There
node
doesn't
claim
need to be a
resource.
node claim. We have an internal representation of cluster state, which is made up of what we call state nodes.
Yeah.
And state nodes basically intelligently flip between using the node or the node claim as the source of truth, depending
Right.
on what stage of the node lifecycle something is in, or if it's a node that's not managed by Carpenter. For example, if you have any self-managed nodes or if you're running Carpenter and CAS in the same cluster.
Right. Okay. So if we go back to the drawing, Alima,
Sorry, I was gonna write that down. Yeah. Uh,
If you want to write, I'm happy to wait if your level of attention and detail is so high functioning that you can
uh,
do that.
Yeah.
That's awesome.
I think generally at a high level, though, you could say the scheduler's two inputs are pending pods and then the current state of cluster. So like your state nodes, whether those are nodes or node claims. And then Carpenter uses that to determine, okay, can these schedule to existing nodes or node claims that are created, but the nodes don't exist for them yet? And if not, then we create new node claims. And then the cloud provider is responsible for actually provisioning instances based off of those node claims.
and okay. Okay, cool. Um, yeah, okay, so I'm just gonna dive into this. First part with initialization. So a big thing is that we want to keep track of like all the DRA device like capabilities, right? So I just kind of like put it in the no claim template. But basically we want to keep track of all the capabilities, yeah, for each node pool or maybe node claim template.
So
Let me
Uh,
bring in one concept. So node claim is a node claim sort of abstracts away a node and makes it a Carpenter native device,
it's kind of.
kind of.
So the way a node claim starts, like a node claim is basically the way I've put it before, is it is our etcd representation of Carpenter's node lifecycle state machine.
Yeah.
A node claim starts out as just like a loose set of requirements. It
So when
doesn't.
you say starts out, you mean like something like 3D there.
What's he mean by 3D?
Oh, in sorry, not 3D, three-dimensional, but the in the visual we're looking at right now towards the bottom, which is in the
Ah,
try adding after creating. So that's a node claim without a node to it.
yeah, and at that point in time, so when we create a node claim, or what we create them from a node claim template, that is just the set of requirements for a node pool. As we
Yeah.
add pending pods to that node claim template, we continue to constrain those requirements until eventually when we launch the instance. And so based on this, like at the outcome, this node claim might be compatible with 15 instance types.
Yep.
Cloud provider at that point is responsible for choosing which of those 15 to launch with, and then actually propagating the information about the instance type it chose to the node claim. It's only at that point of time where I would really call it like a one-to-one proxy with a node.
I see. But it
Up
does have
until,
I assume it has a reference to a node. At some point, there's an integral reference to a node running on the cluster to
yeah,
distinguish it between, like, say, 3B and 3D.
yeah, it would be at, well, so it's the provider ID
Yeah,
that we,
that make that. Yeah, yeah. Provider ID. Let me just real quick. That's something that's stamped onto a node by the cloud provider. So in Kubernetes here, so like Cloud Provider AWS or Cloud Provider Azure, the basic sort of environmental runtime of Kubernetes running in an environment, that stamps a unique identifier on a node and it goes in the provider ID uh,
uh-huh.
property. So
yeah,
that can be used to
Okay.
refer to nodes that node-like things
Okay.
yeah. So
and
every
correlate them with a specific node.
every Carpenter cloud provider needs to implement this create function where core Carpenter says, here's a node claim, create an instance for this node claim. And that returns back all the details about the instance it created, including the provider ID, which at that point gets back propagated onto the node claim.
Okay. Um, okay. That makes sense. I feel like I need that written down on here. Um, but yeah.
Yeah,
Yeah,
well, I think we'll
Yeah.
get there.
Okay.
I think the important thing is, at least for our discussion right now, is during the scheduling phase, we don't want to think of a node claim as a single instance type. We want to think of it as a set of requirements for all possible instance types. And we're just
Yeah,
continuing to constrain those requirements.
Yeah, and is it fair to say that at that phase in the node claim that the set of constraints that a node claim is decorated with more or less represents the set of constraints that are in the pod than in the
Yeah,
workload
yeah,
inputs?
it's the combination of the constraints from the node pool and the constraints from the pod, or really the constraints from all pods that get scheduled to it.
Right. That's yes, exactly. So
Um,
are we ready at this point to think about next steps in terms of code, or are we ready to critically analyze this and then iterate on this and make this more correct? How important is it to get this stuff like sort of really baked in?
I think it's probably relatively important. Um, like the main thing I think we need to figure out is where do we actually represent the DRA information?
Yeah.
And I think this is where it is a little bit tricky because I think we do want to rely on node overlay. Node overlay is still in development. I don't think the implementation, I know the implementation is being worked on. I don't think there's a draft PR up for it because
So for example, node overlay would add resource slice data. So a resource slice in DRA is the representation of a node's device capabilities. So we want that needs to be that is what in Kubernetes enables a pod that refers to resource claims. Those claims are they describe data, device capabilities that are correlated with one or more particular nodes through the resource slice. So if
Mhm.
you can imagine the the flow is I introspect a pod, I find that it has a claim to various scheduling constraints. Those scheduling constraints are discovered in a resource slice, which then has a reference to a node. So that aids the scheduler's decision to schedule onto that node. Does that make sense?
mhm.
And so in Carpenter's in the world of Carpenter, we need to figure out that's what that workload in terms of we're going to update the Carpenter scheduler so that it knows about the DRA concepts. Um, the next thing is we need to help the evolved Carpenter schedule to know how to describe a new node that would fulfill that.
Yeah, and I think one of the key things is just how and where we're representing this resource slice information. Um, I think so. Like right now, I saw in the diagram that you had, like you were calling out resource slice capabilities or DRA capabilities as being a property of the node claim template.
Mhm.
I think the tricky part is the node claim template can be compatible with any set of instance types, which potentially all have different DRA capabilities. So
We just need
wrap,
to they just need to have the sufficient set of DRA capabilities to fulfill the workload, but they don't
You need to have
the set of
all.
constraints in a workload as they might be expressed in a Carpenter representation of that. The Carpenter representation merely has to successfully predict the sufficient constraints that the workload defines. It doesn't have to describe the entire resource slice that's going to emerge once that node comes online. I don't know if that's the distinction that you're making, but
well, the distinction that I'm trying to make is that you could have instance types like with totally different resource slice representations. Like they aren't necessarily going to be related, if that makes sense. Like
do you mean like
you could have a
two?
node pool that has like an FPGA device instance, and then also a node pool with like a NVIDIA device.
That's right.
So I
And
think,
you're right that DRA driver is running on the FPGA DRA driver and the NVIDIA DRA driver are going to produce totally different resource slices for those two nodes.
yeah, so that's where I think the instance type structure. So each cloud provider has to implement a function, get instance types, which returns a set of instance types for a node pool. And each of those instance types, I imagine what we're going to have is that instance type is what has the resource slice information. And that instance type is what we're scheduling against when we're seeing, like, I think
That's right.
in the function in the scheduling code is like filter instance types and then see if there are any remaining instance types to see if like a node claim template is compatible with a pod. We'd be doing the comparison on that point. I think as far as how that DRA like slice information is injected into the instance type object, that is where the integration with like node overlay comes in. And it is something we could potentially like develop in parallel. Like
Yeah,
while we're waiting on node overlay, we can say like, okay, our example cloud provider that we're working on just hard code injects some of this.
for sure. I mean, honestly, we could get started on the scheduler work probably right away. It doesn't even have to be operative. Uh,
Yeah.
I mean, maybe even a phase 0 would be getting the scheduler to successfully, uh, not reject is the wrong word, but to successfully process pods that have DRA metadata and to not have any nodes to send them to. Like that would be a success. At the very least, we could start stress testing. I don't know what kind of stress test you have in Carpenter, but we could start stress testing what those scheduler modifications look like
Mhm.
and start that process early.
Wait, so for having resource slices for the existing nodes, how how does that work?
Yeah, so because this
Like
is,
how do
I think we know the instance type for the existing node. We have the cloud provider information for that instance type. So we should be able to determine based on that what resource slices can be created. Yeah, because unfortunately it's not like,
That it can get more complicated than that later on. For example, like attaching NICs. You can imagine DRA is going to sort of touch
mm,
everything. So well, I'm not mentioning this to complicate things for this conversation. We can punt on
hmm
that. So I think it is fair to scope this effort to um, the set of DRA behaviors that can be constrained to like a discrete instance type will produce a well-known resource slice. So we're only taught that's the DRA world we're living in right now. But
Mhm.
maybe in the back of our minds, we have to be aware that there could be compositions that are ultimately going to be required here, like an instance type with other corresponding attached hardware. And when that hardware is attached, the DRA driver, when installed on that machine, will produce a different resource slice outcome versus if the additional hardware is not attached.
Yeah, I think right now the way we were kind of thinking of modeling this, given that for the MVP at least, we're not anticipating cloud providers being able to intelligently determine what resource slices would be available. So like the way you would support this, I think, in this MVP is if you have like a node pool for which you know you are going to attach this additional hardware to the instances created, then you would put different resource slices in the node overlay for that node pool than you would in for a different node pool which does not have those attached devices.
That's right. And that's the key. That helps the scheduler to know whether or not this or that node pool is the right one for this input. Yeah.
Yeah, I think we have the flexibility to support it with kind of the MVP that's been discussed. It's the room for expansion is going to be how do we automate this discovery down the road and just continue to uh, reduce the amount of additional user configuration that's needed to make use of DRA.
did I write this right? By putting the resource slices in the node overlay for that node pool, it would help specifically in that first stage where we're filtering the instance types for each node pool.
Well, to give some context on node overlay, for reference, there's not a one-to-one relationship between a node overlay and a node pool. You basically, a node overlay has like a set of label selectors. So you could do a label selector saying this node overlay applies to any instances for this node pool or any instances of this type for this node pool.
Mm,
You could also
okay.
not apply a node pool label and just make it apply to every node pool. So it it all depends on how you configure the node overlay. The reason I
Okay.
brought up the per node pool thing is that would give you an option if you wanted to have like two different distinct sets of these instances with like a label you could differentiate on.
In the same node pool.
Well, I was giving like in a different node pool. Like if you
Okay.
have the same type of
Okay, I see.
instances, but you expect different resource slices, a node pool would be probably the
Okay.
easiest way to split that because you could also have your pods target the node pool label to differentiate between the two.
Okay.
But yeah, I guess as far as first steps code implementation wise, because I think that's what we were kind of trying to get to, um, would be how do we do the integration of resource slice into the instance type structure? What does that look like basically? And then I think once we get to there, we can kind of ignore the question of how do we get the resource slices into that instance type. Just let's assume they're there. And then once they're there, how do we integrate it into the scheduler? Like, how do we actually do the comparison between a pod and an instance type? Check if the instance type is compatible with that pod given its resource slice definition. And we can assume at this point that an instance type has one of a set of static resource slices, if that makes sense.
Can you repeat what the first step was?
Basically, how do we encode the instance or the resource slice information in Carpenter's instance type representation?
Oh wait, I thought you said to ignore that question for now.
We don't need to care about how it gets there, like how it gets populated, but we still
Oh,
need to,
You're saying we just need to define a data structure.
yes.
Like we just
yeah,
did it.
yeah, I
Yeah.
see, I see.
Yep, we don't care how we populate that data structure, we just need to define it. Populating that data structure, I think we'll get to that when node overlay, so a little further along.
Okay.
Or like cloud providers could intelligently, however they discover that information, they could populate it. But again, that's not a question we need to answer now.
Okay. Okay, I will want to clean this up more, but I think for me it will be the most helpful to I know like some of this, for example, we talked about how like this is something that we can really push back on thinking about. So it'll be nice to have written out like maybe we can add another section for the different phases that we want to accomplish. Like as in like what is the first problem we're trying to solve, then what is the second problem? Like because some aspects are chronologically dependent on the
How about
other
this? How
part.
about that? Maybe the problem statement is right now, if I were to have a Carpenter enabled cluster and um, I declared a DRA enabled workload, my understanding is that Carpenter would entirely ignore the DRA constraints in that workload and would simply schedule it according to sort of default constraints because it probably wouldn't have very many other ones because that's
Yeah,
how DRA
that,
works.
that is
So
the case.
maybe the first thing we would do is to that's a you could say that's a bug, um, because what would happen is that that pod would just stay pending forever, and Carpenter would add nodes, and I assume it has a TTL, and then it would reap the node, and then would. So the first thing to do would be to fix that bug. Um, I'm calling it a bug is pretty harsh. To fix the behavior where right now the thing that Carpenter should do because it doesn't know about DRA is it should essentially ignore DRA pods and not try to create new infrastructure. When it notices a pending pod that declares scheduling constraints using DRA semantics, it should ignore those. It should say, like, I can't serve that pod. So maybe that's a first. Does that make sense what I'm saying, Jason? Does that sound correct?
It does. I was considering doing this when we released, like I mentioned in a previous meeting, EKS 133 has DRA enabled. I was considering merging that in. The reason I had not was because you could still make use of DRA with Carpenter if you set your pod constraints correctly and you know what daemon sets you're creating.
But that would require the workload author to sort of, uh, if I understand what you're saying, are you suggesting that the workload author would like declare constraints twice for using legacy semantics and DRA semantics?
Not necessarily. So it wouldn't necessarily work for bin packing. Carpenter wouldn't necessarily be aware of how many pods could go on a given node due to resource slice constraints. But depending on how you constrain your pods otherwise, like you could do it, like if you know like only one pod can be on this node of this type, you could use anti-affinity to handle that. Like this is
Right.
what you're suggesting is more in line with how we handle unknown extended resources today.
I see.
Um,
Okay.
but we have had a lot of pushback for that approach because it is impossible to work around to get Carpenter to work with unknown extended resources, which is why for the time being we've kind of left it open. Like Carpenter will provision nodes, and if you get smart with how you do your
I
scheduling,
see. I see.
you can get it to work.
Let's table this. That's an interesting. I think this is an interesting discussion. I'd like to hear more this about this from the community. So you're saying with extended resources, Carpenter already sort of draws the hard line and doesn't.
Yeah.
Um,
So a good example would be huge pages.
I
Carpenter
see.
isn't natively aware of huge pages. If you put a huge page request on your net or on your pod, Carpenter just won't schedule it.
But it must be aware of enough to know not to schedule it.
It's aware in that it sees the request, it sees that there are no instance types in memory that have resources to handle that request, so it doesn't schedule it.
Got it.
So in the case of resource claims, because it's not part of the original like request block that Carpenter was already looking at, then yeah, it just ignores it today.
Okay, cool. Can I give you some homework, Jason? Could you come up with like a reference example of what that looks like and how people would want to work around it? And then maybe we can collaborate and I can come up with the DRA version of that. I
Well,
actually wouldn't
we
mind. Go
can't work
ahead. Go
around
ahead.
it for extended resources today.
Okay,
Uh,
cool.
for DRA right now, since we are ignoring it, we leave it open to be worked around with. I haven't actually worked through an example of how you would work around it.
Okay,
Uh,
I'll give you. I'll start. I'll give you an example DRA pod spec, and you should be able to figure out how you could either with node labels or anti-affinity or something uh, attach it to a node that would confidently work on it.
sure.
Basically, I'd love to bring this scenario to the device management working group and get their feedback on, would you be willing to bless one or the other approach? Because I can imagine um, if DRA adoption is a priority for the sort of ecosystem, then exposing workarounds might be counterproductive to that. strategic goal. Like if the Kubernetes ecosystem is trying to encourage folks to use DRA in the right way, enabling workarounds might go against that. So I just love to get their read on that, and then maybe we could bring that as input. I don't think anybody in Kubernetes gets to tell anybody what to do, but
Sure.
it's more
No,
good input for consideration for particular communities to consider.
no, yeah, no, I do appreciate the input. And for what it is worth, this isn't a workaround we would advertise. We would not document how to do
Yeah, yeah,
this.
yeah.
Our stance would be DRA is unsupported in Carpenter until it is. And if people figure out how to work around it for their own use cases, feel free to. But once official support comes, that is going to be the way to do it in Carpenter.
Yeah, I mean, I haven't thought about this until this discussion, but from my intuition is if I were a cluster administrator, I would want an actor like Carpenter to leave those DRA pods alone. And I feel like I would have more deterministic control over that part of my infrastructure, even if it was like literally manually creating, infra. And in the case of the sort of canonical use case for DRA, which is GPUs, honestly, in most shops, that is the reality. Like people would love to be able to auto scale GPUs all day long and get rid of them when they don't need them because they don't want to pay for expensive hardware. But in reality, people tend to not do that because they're afraid that if they get rid of them, they'll never get it back because of capacity constraints. But the key point is, I would just want to be more in control of that. And if I had an actor like Carpenter kind of sort of working for DRA, that might be more counterproductive than simply knowing that those pods, they're going to sit there, Carpenter's going to ignore them, and I've got some other orthogonal process or actor that will notice those pods needing infrastructure, and I'll get the necessary infrastructure with all the, DRA drivers and all that kind of thing. I don't know if that makes sense, but
No,
that's sort of what I'm thinking about right now.
for myself as an end user, I do agree. I think that is how I would want it to work. We have more data of people wanting it the other way for extended resources, but of course, we only get the data from the people who are unhappy with the current solution. We don't
Yeah,
get data from the people who are happy that Carpenter ignores pods with extended resources it doesn't support because
yeah, yeah.
so so yeah, no, I can see both arguments. Initially we chose just to not touch it and leave it open, but we haven't received feedback one way or another at this point. I think realistically speaking, though, since the feature is still beta, adoption is going to be relatively low, but I know as we move to GA, that may not be the case.
Yeah. I actually have a hard stop in a couple minutes. Alima, do you feel like you have a next step or steps?
Wait, I think I
If
need to. I'm sorry. I think I'm a little slower with understanding this. Right, the expected behavior that we do want is that when we have like the pods that are DRA that have like DRA constraints, it'll ignore it and it'll stay pending. Like that's what the behavior that we want. But right now, if we set the pod constraints correctly, then like like the DRA pod constraints correctly, then Carpenter could still schedule it even though it's like a DRA pod. Is that right?
that's right. The TLDR is that Carpenter will create the wrong node.
Yeah.
Carpenter will think,
Okay.
oh, I know what this pod needs. Identify one or more pieces of infrastructure, create it. They'll become nodes, and then the pod will stay pending. So now you've got extra infrastructure that's idling in your cluster. As I said before, I'm sure Carpenter is smart enough to know that there's a correlation between that added infrastructure and the pod remaining in a pending state. So it'll probably reap it, but it might just do that infinitely. Or maybe there's some back off where it's like, yeah, I actually am bad at this, doing this for this particular pod. So I'm
It
going to
does
stop
not,
trying.
it's going to keep trying to schedule that pod to that node.
Yeah. Yeah. Does that help answer the question, Alima? So
Well,
that's what it'll do
that's
now. And it would do this with it's not like anything special about DRA. It's just that DRA represents a net new set of metadata in the pod spec that describes scheduling constraints. And similarly, extended resources describes scheduling constraints. So the Kubernetes scheduler understands those. If the Carpenter scheduler doesn't understand those, and it doesn't even know to look for them, it's going to look in other places for the pod spec. And in most DRA cases, the constraints are going to be very non-existent. And so it's just going to use default assumptions about how I can build a node to schedule that pod onto, and those assumptions are going to be incorrect.
Yeah. Like if you have a pod with a resource claim for a GPU and its standard resources that it's requesting are just CPU and memory, Carpenter's just going to look at its CPU and memory. And it will provision a pod that doesn't have a GPU or a node that doesn't have a GPU whatsoever. And that pod won't be able to schedule because Kube Scheduler has more information than Carpenter.
Okay, so the only sorry, Jack, I need to go. I can just keep talking to Jason if that's all right.
Yeah, I don't
I
have
actually might not need to go. Just a second.
Okay.
I might be.
Wow. Okay, I'm just confused still. Like, how is this different from this? Because right now this is saying Carpenter will keep trying to schedule the pod to the node, but like, yeah, the pod is pending. Like,
so
is the only different? It's the only distinction between this and this is that Carpenter will just keep the pod in a pending state, but it will not try to schedule. No, I don't see a difference between these two.
Okay, cool.
as far as the pod's
Go ahead,
concerned,
Jason.
it's pending both ways. The difference is Carpenter's not creating a node which can't be used. So right now in the current state, Carpenter will create a node that the pod can't be scheduled to, and that node is
Okay.
potentially just wasted capacity. Now, if you constrain your node pools correctly and you know what the resource slices your nodes are going to look like, this could work. It requires a fair bit more configuration than you would need, and which is why we wouldn't recommend it as like an official way to use DRA.
Okay, wait. Constraint. If we constrain the node pools correctly,
So the whole contract for
Carpenter could
Carpenter,
Carpenter could still what? Okay, in the scenario
I
where
would I
we
would actually I would actually ignore that last comment because I think we don't. I would love to get input from the community that demands that, but then I would probably push back on it. I think the
okay,
important thing to internalize is that the Carpenter's value add contract to the user is that it will create the right nodes that can serve pods that have nowhere to run on. Carpenter
right,
is not able to do that for DRA. It does not know how to create infrastructure that will serve a pending pod that has DRA scheduling constraints. So
right. So this is just the first.
the proper behavior in that case is for Carpenter to do nothing. Because it needs to be honest about the fact that like I don't know how to create a node that will serve this request. So
Okay.
that's missing right now. And that's understandable because DRA just happened and just landed in Kubernetes and Carpenter hasn't yet implemented
Mm-hmm.
DRA. But one of the side effects of that is that you can have Carpenter mistakenly think that, oh, I know how to create a node for that pod, but it actually doesn't. So I think a first
Mm-hmm.
phase would
Mm-hmm.
be to right size Carpenter's awareness of DRA at a minimum to just say, oh, I actually don't know about DRA. So I'm not going to try to do anything for this pod.
Can't do anything about it. Okay, yeah. That makes sense. That makes sense. Okay. Okay, yeah, that makes sense. This is like step one of like many steps, right?
Indeed.
Yeah,
I
so
wouldn't
I'm
even call
I'm
that
just
step one.
wanna
That's like step zero. That's the easiest thing we
okay,
could possibly do. I could probably
gotcha,
do
gotcha.
that
That's just
tomorrow.
okay, okay,
Again, I think that this is going to require some community input before we do it, especially given
okay.
Jason's experience
Yeah,
with the extended resources. We
for what it's worth, I agree with you that that is the right behavior. Um,
Uh-huh.
it's just a question of do you still want to surface workarounds for people who need it? The feedback we've gotten a lot is people want to use Carpenter as their only node provisioning tool. They don't want to deal with
yeah.
self-managed or any other provisioning mechanism, even if it requires these types of workarounds. So taking away the option for the workaround is undesirable. That being said,
Cool.
like,
And we could feature, we could,
oh,
and then we can, we can debate what the default feature flag configuration is. But I
right.
think if there's consensus amongst the maintainers that it's the right behavior, we should definitely allow at least some users, even if it becomes an opt-in, we should allow that opt-in to do what we think is the same thing.
Yeah, I mean, I don't think it would be contentious to say that that is the right behavior.
Yeah, it just might be if we scope this to like it's going to be 12 to 18 months before the full set of DRA functionality is available in Carpenter, and people are like, I want to use DRA now. I mean, I don't know. It's weird to think why you want to use Carpenter as your only provisioner and use DRA, because it's just that's sort of a pathology between the software and the hardware stacks. But
Yeah, I agree, but that is the feedback we've gotten in the past. So,
cool. Okay, cool. Welcome back again. I'm on vacation next week. I think Alima's here, so I would encourage you guys to meet if you have cycles. I think this is really useful. I know that we're all doing a million other things and we're kind of doing this in the background, but I think as things ramp up, I'll be encouraged to spend more active cycles on this.
yeah, I'm definitely not slated to spend 100% of my cycles on this, but it's going to be ramping up in the next couple of weeks how much time I'm able to spend on it. So, yeah,
Awesome. And we've got more resources that we work with that can help on the DRA side, and then we can pull folks in from. I'm sure people are going to be really interested in this once it gets going. So
mhm,
I don't expect it will be hard to find folks to contribute.
yeah. Yeah, definitely before next week, though, I'll be sure to read more thoroughly through what you had from this week, and I'll leave comments on that and add any additional input I have. But yeah, I do think, yeah, as far as if we did want to do any amount of like starting on the code, like figuring out that data structure representation for the instance type, potentially doing this change to ignore resource claims, and then start looking at, okay, assuming this data structure is filled out correctly by some source, how do we do the instance type filtering in the scheduler? Probably just starting with like creating new node claims.
Mhm. Okay.
All right. Somebody remind me maybe tomorrow before I go away to check a YouTube playlist to see if this just automatically uploads. I think that
I
would be
think
the same flow, but I don't know if it's set that.
I think it does, and it's usually pretty quick.
Okay,
So
cool.
at least it does for the meetings that we run, the other meetings we run for Carpenter for issue triage and working group.
Okay. See everybody soon. This has been fun.
Yeah, we'll see you
Mhm.
guys.
Thanks, Lima, for all that prep work. I know that was a
Yeah,
lot
of
of work.
course. Thank you for being so patient with me. And Jason, I'll see you next week. I'll probably interrogate you.
All right, sounds good.
Okay. Bye, y'all.
Yeah, see ya.